When we look at a diagram like this, we're given two actual mirrors. You have a plane mirror here and you have a convex mirror here. And the question asks, will the security guard standing with his back to all these people, based on where the mirrors are actually placed and where the security guard is in response to those mirrors, will he be able to see everyone in that area or not? So in order to you get 1 mark for checking the right box, but the vast majority of the marks come from drawing both your ray diagrams here. Okay, so in order to actually figure this out, we're assuming that the eyes of the security guard are at his head. All right, and first things first, we're going to do the actual planar mirror. So for this kind of activity, you do need a protractor, because with a ruler, you're actually going to draw from the person's eyes, going to one extremity of the actual mirror, and that was poorly drawn, so I'm going to try doing that again with just my finger. And okay, so that's going from his eyes here and then going to this end here. So if I had a ruler, I would have my two angles of incidence here, okay, at the ends of the actual mirror. So I would have a normal coming through here, and I would have a normal coming through here. If I measured these actual angles of incidence, what do I know about my angles of reflection? They are going to be identical to my angles of incidence on a planar mirror, right? So if I know that my first ray is also going to have whatever that angle is. Now, I would expect you, answering a question like this, to actually measure this out and show me the angle. Okay? And all you do is you take a ruler and you go from, one spot where at the front of that gentleman's head to one side of the mirror, and then the same spot on the gentleman's head to the other side of the mirror. By drawing the normal out of both of those sides, both of those angles of incidence, you can then determine the reflected angle. And in so doing, you would have the exact same angle here, and you would have the exact same angle here. So in theory, if this gentleman is standing where he's standing and looking at both of these mirrors, okay, and he doesn't, obviously not going to be looking at them at one time, but if he can see both of the people here because they're in the line of sight of that mirror. So when we look at a planar mirror, it's pretty simple. We've got angles of incidence and angles of reflection. We know that we're going to the two extremities of the mirror, and whatever that block is coming out of the mirror, all of that shaded green space, that person can see, the person in question, the security guard. Where it gets a little bit different with the actual images or the actual area that can be seen with a curved mirror, you actually have to use your center of curvature. There's a reason that they give you that center of curvature coming out at the back of the mirror, basically through the wall. And that's to help you draw your normals for the mirror. Because we know that at any one point on the mirror, if I was to draw a line through the mirror and linking it to the actual center of curvature, okay, I would actually get perpendicular, that line would be coming out of the mirror perpendicular to that surface. So if I sit here and I draw and actually we'll go with the same color. If I sit here and draw my normals, the exact same color I used over there. So I've got one normal here and I've got one normal here. Okay? At those spots in the mirror, that is the perpendicular line coming out of that mirror. Now, the same sort of deal is going to happen here. when I actually draw my rays coming out of the person's eyes, I'm going to have one ray go to one end of the mirror, and I'm going to have the other ray go to the other end of the mirror from the person's eyes. So exactly the same thing gets done here. We've got one angle of incidence here. We have the normal in orange. Therefore, we will have one reflected angle here. Okay, these two angles are the same. Both sides of the normal. The same thing happens on the other end of the mirror. We've got our normal, and we've got one angle here, and we're going to have exactly the same angle here. So in this case, this mirror allows us to see a much wider span. So if you're supposed to be answering the question, can the security guard cannot see the customers in the store, what would your answer be? The security guard can see all of the people in the store where he's standing using those two types of mirrors. Remember that when the security guard is looking out, he is looking out at a light ray going from here to the mirror. Okay, and it's being reflected in this direction. He's going from here to the mirror, and it's being reflected in that direction. Same goes for this side. Into the mirror, reflected in this direction. Into the mirror, reflected in this direction. So anything that goes in between that is visible. Okay, the trick to doing these mirror questions is using the actual normals that you draw in on each mirror. The planar mirror, it's just perpendicular to the actual flat surface of the mirror on both ends of the mirror. The curved mirror, you use the center of curvature and you just make a line. So if I've got my center of curvature, so if I've got an actual line here and my center of curvature is back here, my normal is going to leave the center of curvature and go out, and it's going to leave the center of curvature and go out. So if a person's standing over here, okay, and the angle comes in here, whatever that angle is then going to be reflected here to be identical. Okay, same goes. If that person, and we'll actually use a different color, if that person's coming all the way back here, okay, and it wouldn't work if he was behind the actual mirror. Okay, let's say I actually drew this to scale. Whatever this angle is here, you're actually going to see more or equal on that side. So it all comes down to drawing these two normals. Okay, and the normals go from the center of curvature and they basically brush up the outside most point of that mirror. So whatever point goes and matches that normal, goes into the base of the mirror there, you're going to have your angles right here, okay, matching. Your incident angle is going to be equal to your reflected angle. So if I have a curved mirror, what I tend to do in terms of figuring out where the center of curvature is, and you will be given this center of curvature. There's going to be a dot. Anytime that you get a question like this and you get a curved mirror, there's going to be a dot accompanying it telling you where the center of curvature is. Okay, so on this previous image, the center of curvature was actually given to you. It will always be given to you. So if I draw an actual circle here, I actually just imagine that circle going on, okay, here, and I imagine that circle going on, and then I give myself a center of curvature. That's how I come up with roughly where my center of curvature should be. But in reality, the mirror is still only this big, okay? This is still my only mirror. So I'm going to draw my normals. I'm going to go from the center out this side. So at this point in the actual mirror, that's perpendicular. That orange line is perpendicular to that point in the mirror. Okay? At this point in the mirror, and actually, here, try that again. At this point in the mirror, right here, okay, that orange line is perpendicular to that other end of the mirror. So if something is standing right here, and it's coming in like this, it's going to be a very, very small angle here. So that means it's going to have a very small angle there. Okay? So if somebody is standing right here, they won't be seen. Right? And the same thing goes for this angle here. Okay, if I go into here and assume that that's actually properly drawn. Okay, so I'm going to have a really big angle here, right? Equal. If I've got somebody that's standing over here, they will not be seen. Because the only things that are seen are in the middle of all of this, right? The only things that are actually seen are in the middle of all of this. So if person X is here, no. Person Y is there, no. Okay?